بيكم أعزائي الطلبة والطالبات ومع حلقة جديدة من مادة الساينس لبريب 2 تحت رعاية وإشراف وزارة التربية والتعليم. We are still in lesson 3 about the main groups in the modern periodic table. Last time we talked about the alkali metals. Actually, or exactly, we talked about the physical properties of the alkali metals. We talked about their luster, their densities, and how this property graduated in the table. Inshallah, we are going to study today together some chemical reactions for the alkali metals. The reaction actually with water, how do some of the alkali metals react with water, what are the products, and how to test for the products. And as you see from the very beginning, this unit is connected to each other. When you study one of the lessons, that means you are or you will expect the rest of this unit. فيلا نبتدي مع بعض الحلقة النهاردة ونشوف هنتكلم عن الألكلاي ميتالز ونقول ايه معلومات زيادة النهاردة. يلا let's go. زي ما قلنا هنتكلم النهاردة عن some chemical properties for alkali metals. Lithium, sodium, potassium, rubidium, and cesium. Of course, because they are in group 1A, that means they have just one electron in the last energy shell for all of them. Lithium has one electron, it has two levels and just one electron in the last shell. Sodium, the same, has three energy levels and one electron in the last shell. And so on. For potassium, it has four levels and one electron in the last shell as well. So because all of them, they have one electron in the last shell, so they have almost the same properties. And you study this about الجروبز في الفيرست lesson. في الفيرست lesson كنا بنتكلم عن الجروبز وقلنا إنه المفروض نبقى عارفين إنه الاليمنتس with the same group have similar properties. They are all have monovalent. They are monovalent. Mono means one. They have one electron in the last shell, and they are metals, of course. So they are going to lose the outermost electrons. They tend to lose their valence electrons during any reaction, and they change into positive ion. So they will change into positive ion after losing one electron. Because they are active, they are very active. Why they are very active? Why do you think that alkali metals are very active? We have different metals in the table, but alkali metal especially, they are very active elements. Why do you think that? They are very active actually because they have just one electron, and it's easy to lose such electron in any reaction, so they are very active elements. Because they are very active, so they maybe react immediately with moist air. Yani if you expose them to air, they will rust so fast, or react with moist air, oxygen in air, water vapor in air. فبيعملوا reaction سريع جدا. So because they are very active metals, they are kept under kerosene or paraffin oil. If you want to keep them, or if you want to save them in a place, they are kept in kerosene. Kerosene, it's a liquid. To preserve them, or in paraffin oil. Actually, you should put them in a media or in a place where they are surrounded totally by a substance, and this substance will prevent the reaction with moist air. عشان كده بنحطهم في البارافين oil أو الكيروسين. يبقى when we ask you why they are kept in paraffin oil or in kerosene, يبقى نقول له علشان to prevent them from the reaction with moist air. Moist air, it means water vapor in air. As they are very active metals. يعني if you leave them by their own this way, لا هيعملوا reaction مع moisture in air. فعشان نحافظ عليهم ما يعملوش reaction لأن this may cause damage or fire. To protect them, we put them in kerosene or in paraffin oil. What else from the chemical reactions of alkali metals? I just want you to note that in lithium, اللي هو first one, lithium, Li, their chemical activity increases as the atomic size increases. It's زي ما درسنا قبل كده في lesson 2 size as you move down in the group it increases. As you move down in the group the size increases. That means potassium has bigger size than sodium and sodium has bigger size than lithium. So the chemical activity of each of them increases as you move down because the size increases. Because this will make the atom, it's easier for the atom to lose one electron اللي هو outermost electron, one electron in the last shell. هيبقى it's easier for the atom to lose it in case it has a big size like potassium. عشان كده بنقول if you want to arrange them according to their activity or chemical activity, you will find that the most active one, of course, it's cesium. خلينا نتكلم على lithium, sodium, potassium. Potassium is more active than sodium and sodium is more active than lithium. But about cesium, cesium is the most active one because it has the biggest size in all of them. Now, give reason question. Why do you think that cesium is the most active metal in the periodic table? Actually, cesium is the most active one at all. Why do you think? We just said it before. Because cesium has the largest size. As it has the biggest size, it can lose easily the one electron that's in the last energy shell. Now, let's see this video. It's talking about the alkali metal and some of the properties of alkali metals.
Let's investigate the reactions of the alkali metals. Alkali metals are stored in oil to prevent them from reacting with air and moisture. See lithium's dark appearance? The metal corrodes when exposed to air. But when lithium is cut, you can see the shiny metal. Now watch how sodium corrodes when cut and exposed to air. Potassium reacts so quickly it's hard to even see the metallic luster. Now, notice where these metals are on the periodic table, and think about what you've just observed. What's the trend in reactivity going down the periodic table group? If you said increasing, you're right. Alkali metals reacting in water can be pretty exciting. Here goes lithium. See the metal floating and the fizzing? Did you hear the pop? That's the flammable hydrogen gas produced in the reaction. Alkali metals produce soluble hydroxides. That's why this indicator turns pink, to show a base. Watch sodium react with water. And now watch potassium. Did you spot the purple flame? Wow! What alkali metal was that? It's one of the most reactive, cesium.
Now, did you see the reaction of cesium? Did you see that when the beaker breaks because of the reaction of cesium? Did you see that the elements, when they are just exposed to air, they lose their metallic luster and corrode أو بيحصل لهم زي بيصدوا كده بيبقى they lose the luster بتاعتهم. This is because they are very active elements, and when they are exposed to air or when they react with moisture in air or when they react with water, they, as you see in the video, like مثلا الليثيوم. خدتوا بالكم لما الليثيوم float over water surface and then sodium and then potassium? طب did you see the reaction in case of lithium is a little bit slower or weaker than the reaction of sodium and then the potassium, and the most big one is cesium? طيب the reaction of alkali metals with water, it gives alkali solution. Alkali solution, you know of course what is alkali solution. It's the substance that turn the indicator or the litmus into blue. And in addition, hydrogen gas evolve and hydrogen burn, because this reaction, the reaction of alkali metal with the water, it gives a little bit heat. It produces heat as well. فالheat produced, it may cause the hydrogen to burn, and hydrogen burning gives a pop sound. يعني ما قلنا صوت زي طرقعة كده، تك يطرقع كده. يبقى this will give pop sound. And here the reaction, sodium plus water, it gives sodium hydroxide and hydrogen gas evolve. Potassium and water, it gives potassium hydroxide and hydrogen gas evolves. Now, let me explain these two equations to you in the board. Let's explain now the reaction between sodium and water. Sodium, it's Na plus water, it's H2O. This will give sodium hydroxide, it's NaOH plus hydrogen gas evolve. You studied before that how to balance an equation. Balancing equation, it means the total amount of reactants should be equal to the total amount of products. يعني ما ينفعش يبقى في reactant عندي مش خارج كproduct. So if you count with me now, you will find we have here in the products we have 3 hydrogen atoms, but here in the reactants we have only 2. So this is not a balanced equation. To balance it, let's put 2 here and 2 there. So let's count again together. 2 sodium atoms are in the reactants and they are now in the products. We have in water 2 molecules of water, 2 of H2O, 2 molecules. It means we have 4 hydrogen atoms and 2 oxygen atoms. Yes, we have here 2 in hydrogen and more 2 here, but they are all 4. And finally, the oxygen, we have 2 oxygen atoms, and here the product contains 2 oxygen atoms. Let's discuss this with more details. If we said that in the sodium react with water, water can be written this way, HOH. It's hydrogen connected or joined with OH or hydroxide group. In fact, sodium, as it's a very active metal, so it can replace this hydrogen. It can replace it, can kick it out. يطلعه بره, يطرده. And then sodium combine with the OH, NaOH. What about the hydrogen? This produced hydrogen can't exist freely. It should be one more atom of hydrogen combined with this one to give the molecule of hydrogen, H2. Now, from where can we get this other hydrogen atom? Good. By adding more water. Yani when we have 2 molecules of water, one of the molecules break down so the sodium can replace one of the hydrogen atoms. It gives NaOH, but this hydrogen remains solely. No, this is not correct. Any gaseous atom should be exist in the form of diatomic molecule. Diatomic molecule يعني المولكيول بيبقى فيه 2 atoms. So that means for this reaction to happen, at least we have 2 molecules of water this way. So this will give a 2 hydrogen atom. And what about the OH? يبقى عندنا كده one more OH. عشان كده هنحط صوديوم تاني to react with this. يبقى again أنا عندي 2 of the sodium react with 2 molecules of water. This will give 2 NaOH, sodium hydroxide, and sodium hydroxide turn litmus into blue plus hydrogen gas evolve. And the hydrogen gas, as we said before, it burns with bob sound because this reaction produces heat, and this heat may cause the hydrogen to burn with bob sound. This reaction is dangerous. If you want to make it in the lab, be careful and take just a small piece of sodium, very small one, and put it in a big amount of water so this will not be harmful for you. يلا نكمل بقية السيشن بتاعتنا with the rest of the reaction the other alkali metals. By the way they are all the same. يعني زي ما بنقول sodium Na plus H2O it gives NaOH. The same potassium plus H2O it gives KOH potassium hydroxide, and يعني all of them, all alkali metal will give the same reaction. Okay, let's go. يبقى ال general properties of alkali metals. أول حاجة قلنا عنها في الجزء ده إنه they have lower density. قلنا معلومات عن إن هما float over water surface. And then قلنا how to write this reaction, the reaction of alkali metal with water. قلنا لما يبقى عندنا sodium, for this reaction to happen at least we should take 2 atoms of sodium to react with 2 molecules of water. So this will give sodium hydroxide, which is alkali solution that turn litmus into blue, and the hydrogen gas evolve, and hydrogen gas may burn with pop sound. زي ما قلت لكم take care وانتوا بتعملوا الرياكشن ده if you want to make it at the science lab. The same reaction goes for the rest of the elements. يعني if you replace sodium with lithium with potassium, the same reaction. أقدر أكتب أي letter أو أي symbol of the other elements. لو قلنا potassium, it means I need 2 atoms of potassium with 2 molecules of water, and this will give 2 molecules of potassium hydroxide and hydrogen gas evolve. This is the reaction. Now, did you know from where we get this nomination for group 1A, alkali metal? جبنا منين الاسم ده؟ This is very simple and easy. فبيقول لنا هنا الجيف reason question بيقول لي ايه؟ Elements of group 1A are known as alkali metals. Yes, of course they are alkali metals because they react, or their reaction with water gives alkaline solution. The alkaline solution احنا قلنا عليه قبل كده ان هو ال solution that turn litmus into blue. You should support your answer with writing the equation. The 2 sodium atoms react with 2 molecules of water, and this will give sodium hydroxide and hydrogen gas evolve. يبقى the nomination of alkali or alkali metals, this is because they react with water giving alkaline solution. Here you have a video about the reaction of one of the alkali metals in with water and the effect of litmus on this product.
All the metals do not react with water at a similar rate. For example, when a piece of very active metal like potassium is added in a trough filled with cold water, the potassium burns spontaneously on the surface of the water. This reaction produces aqueous solution of potassium hydroxide. Potassium K plus 2 molecules of water H2O react to give potassium hydroxide KOH with the evolution of hydrogen gas.
I guess this video visualized the reaction for you. Now, let's have some questions from the Egyptian Knowledge Bank. Look at the figure. Here we have a figure. As you see, it contains 2 pictures for 2 bakers. One of them with more reaction. We know that it's more because of the fire in the baker at the left side. So, which reacts more strongly with water? Sodium or potassium, and why? What do you think? Which baker contains sodium and which baker contains potassium? What do you think from this reaction? Of course, you know that potassium, as it has bigger size, it has more reactivity with water, so it reacts so fast and very strongly more than the sodium. So potassium is the one that gives this fire. This is potassium, by the way. يعني هو ده بتاع البوتاسيوم لأن الرياكشن بتاعه much more stronger than sodium. Now put right or wrong. Sodium and potassium are kept under the surface of kerosene. Is that right or wrong? Yes, it's right. Why do you think this? Because قلنا قبل كده إن هما they are very active metals, so they are kept under kerosene or paraffin oil to protect them from the reaction with moisture in air. Now, give reason. Sodium fires, if we have a fire in a place where this place contains sodium for any reason, in a factory or in a lab or any place. So sodium fires are not put off with water. ما ينفعش نطفي الحريقة اللي فيها sodium with water. Why? Yes, good. Because sodium is very active and it can react instantly with water, and this will cause the fire to increase more and more. It will not put off. So because sodium reacts with water and hydrogen gas evolve, which burn with pop sound. And as I said before, you should support all the time your answer. It's better to support your answer with writing the equation. Lithium is the most active metals in group 2A. This is put right or wrong question. What do you see about this statement? Do you think is it right or wrong? If it's right, why? Because of what? Or if it's wrong, what is the wrong in this statement? Lithium is the most active metal in group 2A. Of course, this statement is totally wrong. We have two reasons to make us call this statement is wrong. The first thing is about 2A. Lithium exists in group 1A, not 2A. That's number one. Number two, lithium is not the most active one. The most active one in group 1A is cesium. But lithium is the least. أقل واحد فيهم في الactivity بتاعته, بس هو very active, of course. Now, as usual, we may have such a question where we have a part of the table and we are going to talk about some of the elements in this table. First question is telling us about which element is considered from S block. يلا كده, nominate all the elements that are in S block. Good, they are all in S block, L, X, A, B, F, and M. طيب, what else? Which element is considered from P block? All the right side elements, Y, S, E, Z, and D, they are all in P block. Which element is considered from D block? D block in the middle of the table. We have only one element here in this table, it's C. Mention the valency of L. Where is L? L is here. So if you remember, L now contains two energy levels. It has two levels. It means we have the first level contains 2 electrons. The second one contains 1 electron because it's in group 1A, so الفالنسي بتاعه 1. This is the way to answer, أو directly تقدر تقولها لأنه هو في جروب 1A يبقى الفالنسي بتاعه 1 لأنه من جروب 1A monovalent. Find the atomic number of F. Where is F? Here in group 1A as well. In the fourth period يبقى we have 4 levels. That means F contains 2, 8, 8 and 1 electron in the last level. يبقى all of them is 19. What happened when element A react with water? Element A, it's like any alkali metal, the same. زي ما اتكلمنا عن الصوديوم, الليثيوم, البوتاسيوم, هنكتب نفس equation, but instead of writing Na, you may write A. A is a symbol or abbreviation for unknown element. مش لازم اكتب اسم الاليمنت بنفسه. هنا الكويستشن بيسألني على ايه, فانا هشتغل بالنيم اللي هو ذاكره بالكويستشن, which is A. A يعني 2A زي ما كنا بنقول 2Na plus 2H2O, it gives 2AOH. AOH, it's A something, some element, hydroxide plus hydrogen. The last question, which is which element has the largest atomic size in period 4? In period 4, the biggest size will be in the element at the beginning of the period, which is F. One more question here. From the previous table, mention 2 elements after changing into ions. They will have the same atomic structure of element G. G is inert gas. Here is G, inert gas. That means we need elements to whether lose or gain electrons to look like, to have the electronic configuration like G. Here we have a lot of elements. You may mention from the metals A and B, or from non-metals by gaining one more electron, يبقى E. يبقى we have more than 2 elements, in fact, that can satisfy this question. Now I guess we have got the end of our session for today. أتمنى تكونوا استفدتوا من السيشن بتاعتنا النهارده. Stay safe وخلوا دايما البريودك تيبل جنبيكم وانتوا بتحلوا أي question, and this will help a lot. See you next time إن شاء الله. Thank you.